not just going to stay up in the air. We're actually going to go up way beyond where the air actually finishes. So we're delighted to welcome Coda partner Kongsberg Satellite Services, and Laura Abuja is going to talk to us about using satellite data to support decommissioning of energy assets. Welcome, Laura.
Thank you very much. Welcome, everybody. I think, let's make this decommissioning session kind of different. I'm talking here about how to use satellite data to support decommissioning activities. I'm Laura Buja. I'm part of the Earth observation team, and I'm going to explain what is that about within Kongsberg Satellite Services, and then how we really want to support this sector within the decommissioning, not only in Australia, but worldwide. Yeah, so as a little bit of introduction, you might hear about Kongsberg and KSAT, that is Kongsberg Satellite Services, as said. It's 50% part of Kongsberg Defense and Aerospace, and the other part, more or less 50%, it's part of Space Norway, and Space Norway within the Ministry of Trade and Fisheries. So we know quite well what it takes to monitor maritime domain and maritime awareness during the last 25, 30 years. So that's more or less what is within KSAT, all the knowledge there. Let's go just straight to the point, what is about the different three piles of our business model within KSAT business area. Sorry, one first is the ground segment of the ground network. KSAT is very well known because of the different antennas spread all around the world. We have 27 different sites. I will show you later in a different map. And that allows us to deliver different services in near real time. And that means from acquisition of the satellite taking a picture, downlinking into our antennas, then processing and delivering to our customers. It takes less than 2 hours. There's customers that receives our reports in 20 minutes. And I will explain a little bit later why this is so important into the decommissioning sector. I'm here with my colleague, Alistair Cannell. We have a booth in A19, and we are part of the Earth Observation Division, as you can see in the middle. This division of KSAT takes care of that imagery that's, as said, downlinks in the antenna, and we then create the different reports, mainly oil spill detection, vessel detection, but also emerging markets, which relates with methane emissions, also the ground movements from Earth, mining as well, multi-mission and near real time, and we take care of the planning and tasking of different satellites related with Earth observation. And then the third pile of the business areas is government and programs, so they take all about defense and security that I'm not allowed to speak here. Yes, so within the Earth Observation Services division that, as said, and my colleague and I are representing in Australia this week, it's mainly the maritime surveillance and security services. So we have large experience in delivering this near real-time oil spill detection and vessel detection, as said, because of the large knowledge within the maritime domain through the last 25 years, 30 years. And we are very good also sending reports in near real time detecting ice. So every time there's an operation that needs safe costs, but also have safer methods of execution. For example, through ice navigation, we can also support that. Then, as you can see, there's different also applications within the environment monitoring, forestry and land monitoring as well, and then how to process data and satellite imagery. Just to give you an idea where we are based in Norway, here in Tromsø, above the Arctic Circle. We are more than 300 people living here, and we have also offices in Oslo, Stockholm, and Colorado, and spread all around the world. We have also antennas here in Tromsø, but a little bit up north in Svalbard. Here we have our largest network of antennas. So that that allow us to have every single kind of contact with every satellite that it's traveling the Earth. So we contact them and downlink super fast to deliver the reports I was talking about. We also have antennas in Troll, but as said, there's 27 different sites spread all around the world. So that gives us a unique position in this Earth observation market to deliver all the information that we can extract for sensors, no matter if they are SAR, optical, methane detection, satellites, wherever. We collect all that information, download in our antennas, and then send the reports to our customers. To give you an overview of what the maritime services we can provide within a year, here is kind of a summary. We have analyzed more than 70,000 scenes in a year, detecting more than 10,000 oil spills and more than 5 million vessels. So maybe you will ask, like, why KSAT is doing in Coda Seattle today, why it's so important, right, to have satellite imagery during our operations, during decommissioning activities. Well, basically to save costs. This cost a fraction of the cost of sending vessels, aircraft to remote areas that I said in the previous presentation. Probably no one's been in situ during the last years since then. Also, it's emission-free because satellites are orbiting the Earth already. So there's no emissions in that sense, sorry. And mainly because with satellites, you can cover 4 million square kilometers in an hour, while doing that with vessels and aircrafts, it takes you more to cover that kind of surface with a single hour, as you can see there. With vessels, you have to take 1,000 square kilometers, and with aircraft, you will be able only to cover 35,000 square kilometers. So probably you are not familiar with the different sensors, but here is a summary of all that we consider our best class to download, analyze, and deliver in near real time. We have an in-house processing. As said, we own the antennas. We don't own the satellites, so that gives us the idea what is best cost for different projects, what is the best resolution, what is the best coverage. So we are satellite agnostic, but we know well which kind of sensors fit into the different solutions. Also different areas of interest. It's not same monitoring and assets here in Australia than in northern Norway. Also because of weather, because of different revisit time, because of different licenses. So we have that experience, and we can advise our different customers about what different sensors will fit best in their needs. To go and talk about a little bit of our oil spill services and how good our oil spill reports are for our customers, here you can see a SAR imagery, and that means it can be used no matter if it's daylight or night, or if it's cloudy or not. It's a sensor. It's a type of sensor that can go through clouds. So that gives you the idea of what is going on around the assets. So this kind of monitoring is very good not only to detect if there's any oil spill, but also to document clean sea operations, right? To see to the regulators and also the authorities that everything is going well during operations and during the commissioning activities, of course. So it demonstrates that there's no oil spills during those activities. Also, we can predict where that oil spill, if detected, goes. It says there data for a spill monitoring open drift. So we have a model that gives you the idea where in the next hours that oil spill will move. So then different operators can prioritize different areas and how that oil spill will hit different areas, maybe reserve areas. So then you can prioritize, as said, different ways of going and clean that oil spill. And yeah, we have different semi-automatic analytics behind all those oil spill monitoring, oil spill reports that we download in our antennas. So as it says there, we also can identify the difference between an oil spill and an algae bloom, also the difference between an oil spill and a natural sip, because it could happen. So all that information is collected in these kind of nice reports with the kind of acquisition time, set coordinates, and so on. So this is a very nice example we always want to show, and it's the example of NOFO that I'm not able to pronounce what that means, but it's the Norwegian regulator of putting all together as the operators. And it's this project aims to collect every single day all the assets around Norway. So every day we have a daily monitoring of their assets just to make sure that all the operations are going well. So no oil spills, no vessels around the assets that might create any kind of accident, and then deliver this in near real time as said. As an example of near real time, one of our main customers is the European Maritime Safety Agency. So with all the antennas around the Mediterranean area and up north, we are able to deliver these reports in less than 20 minutes since the acquisition. So at this moment, the satellite acquired the image, download, analyze, and deliver to the European Maritime Safety Agency. It only happens in minutes, which is critical, not only for environmental monitoring, but also for border controls and security. When it comes to monitor different assets, we are able to use different optical data, which is similar to the drone slide we saw previously, but of course this doesn't need someone to fly the drone and go to remote areas to fly the drone, sorry. But to have previously this kind of information and then decide where to fly the drone, where to fly the aircraft, and so on. So that is useful for offshore decommissioning activities, but also we can do the same thing onshore. So here you see an example of an asset onshore, and then you detect over the time that there was kind of a little bit of leak here, and then you see that it is spread around the assets. So you can also monitor in the different pipelines and then take care of the maintenance of that asset or platform. So our main focus here is to collect all those different services, all those different knowledge we have along these years, and put it together to the decommissioning market. And together with the European Space Agency, we are running this DECOM program that gathers 4 main services that I will show you here. First of all, and the main one, of course, is the oil spill reports. With the multi-mission approach I was talking, we aim to collect as much as information in near real time, also to collect drift model and thickness of that oil. Put together that information with the vessel detection information, because during decommissioning activities, not only in the planning, operating, and then after, may different vessels go around and not even related with the decommissioning activities. It could be fishing activities, so all that information will be collected. We aim also to put together greenhouse emission in our reports, and of course the risk and water quality around those assets. So the more information we aim to have before, during, and after decommissioning is what we aim with this use of satellite data. Thank you very much. As said, we are in booth E19. Maybe there's only 1 minute for questions.
Yeah, thank you very much indeed, Laura. And please, questions from the floor. And I'm told there are prizes.
If there's questions, I have some gifts to deliver.
Hi, I have two questions regarding the oil spill.
Yes.
One is, what's the smallest area you can detect? And the second is, for ASAT to be monitored, how frequent can the satellite be looking at that area?
I will start with the second question. It could be monitored depending on the area of interest, but normally twice a day, at least daily, because of all this multi-mission approach I mentioned. So we don't only trust in one constellation, but in every single asset, platform space assets that are orbiting. And about the resolution, the spatial resolution you mean for oil spill, that's tricky to say because depends on the wind and different areas, but I will say around 10 meters.
Any more questions for Laura? If not, thank you very much indeed.
Thank you.
Please join me in thanking Laura for an excellent presentation. Thank you.